This question should look very familiar to you. You've seen it before. Make sure that you're okay with both of these because they will be coming up again very quickly. You can tell if a function's a quadratic function if the highest power of x is 2. Also, number 2, the shape that all quadratic functions make is a parabola. So section 2 in chapter 4 talks about standard form of a quadratic function. If you recall, the last stuff we talked about in section 1 was vertex form. In vertex form, you can very quickly see a vertex. You cannot see a vertex in standard form. Part of the challenge here will be finding the vertex before you can do anything else. There's a whole bunch of information for you to copy down. Pause the video to copy it, and then we'll discuss it. Standard form is written there for you, ax squared plus bx plus c. Remember, we've talked about the fact that the vertex is hk multiple times, and there is no h or k in that standard form. The axis of symmetry can be found by doing negative b over 2a because, and I'll highlight it a little bit further on down the page, h is negative b over 2a. That's super, super important for you to remember. The vertex is still going to occur at hk, but you have to find h by doing negative b over 2a, and then you have to find k by putting the h value in to get a k value back out. Also new for something today is this concept right here. The y-intercept is 0c. So instead of picking a value close to home to graph and using the axis of symmetry, like we did in the last lesson, we're going to use the y-intercept because that value is going to be readily available to us. And then still the last bullet talks about whether it opens upward or downward. Positives open up and negatives open down. So you'll notice that these equations look considerably different than what we did before. There's no h, there's no k. What you do know in this information are a values, this one's 1, it's understood. B values, this one's 2, and this one's 3. So the first thing you're going to do is find h. To find h, you do negative b over 2a. So I'm just substituting. My b value is negative 2. Well, my b is 2, sorry, but it is negative because there's a negative in front. And then on the bottom, it should be 2 times a, so 2 times 1. And then just evaluate that. On the top, I have a negative 2, and on the bottom, I have a 2. So I know that h is negative 1. I'm going to cloud it. It's not final answer, but it is very important. The next step is new as well. If you have that h value, which again is the x value of the ordered pair of the vertex, you can find the y value, or k, by substituting. So if I want to find k, I'm going to take that negative 1 for h and put it into the original equation everywhere that I see an x. So all I did was I put it here for x and there for x. And then you can use the calculator if you need to. Negative 1 squared, don't forget parentheses, is 1. 2 times negative 1 is negative 2. Recopy the 3. I know that k is 2. So those two pieces of information together give me a vertex. Remember, the vertex occurs at hk, so this one occurs at 1, 2. So plot, or sorry, negative 1, 2. So plot that ordered pair. Negative 1, 2 is right there in quadrant 2. And I also have an axis of symmetry. That's x equals h, so this one's x equals negative 1. So I'm actually going to put that on there as well. I don't know if those colors are going to match exactly. But it ends up going right down your vertex. Now that's important because that's going to help us mirror just like it did before. So at this step in the last lesson, we picked an x value close to our vertex. We would have picked like 0 or negative 2. But in standard form, we have something new. And that new piece of information is called the y-intercept. Your y-intercept is always 0, c. In this case, 3. That should be a point on the y-axis. 0, 3 occurs right there on the y-axis. And then I'm going to use that axis of symmetry to mirror it over. So if I mirror that 0, 3 over to the other side, I get the next point. And then all you need to do is connect them with a u and not a v. I always like to double check to make sure it opens up and is stretched or compressed appropriately, and this one is. So you're all done. All right, number 2, same situation. I have an A of -2, a B of 8, and a C of -5. So we're going to find H first. To find H, you do -B over 2A. So -8 over 2 times -2 is -8 over -4. My H value is 2. To find K, I'm going to put that back into the original function everywhere that I see an X. So -2 parentheses 2 squared plus 8 times 2 minus 5. 2 squared is 4 times -2 is -8. 8 times 2 is 16 minus 5. Again, use the calculator. You should get 3. So that gives me a vertex. Your vertex occurs at HK. So this one's going to occur at 2, 3. 2, 3 is right there in quadrant 1. And I know that I'm going to have an axis of symmetry at x equals 2. That's going to be a vertical dotted line that goes right down the vertex. I'm going to use that to mirror. And what am I going to mirror? The y-intercept. In standard form, instead of picking a value, just use 0c. In this case, our c is -5. So 1, 2, 3, 4, 5 puts me right there on the y-axis. And I can use that mirror to go to the other side. If you notice, that blue point is 2 units to the left of the axis of symmetry, so another mirrored point would be 2 units on the right. Connect them, and you should be good to go. This graph, to me, looks very skinny, and it opens down, which makes sense because your A value is -2. It's reflected and stretched. Pause the video to do you try it. Sorry, that one doesn't go through as nicely as it should.